Hello, guys. In today's grade 12 physical sciences, vertical projectile motions exam clinic, we are looking at a question paper from the Western Cape. This is their physical sciences paper 1 of September 2024. All right, as you can see here, this question is a 17 marks question. And it being a 17 marks question, it means we should spend exactly 17 minutes. Okay, it means we should spend exactly 17 minutes. Right, so let's see what this question has for us. Okay, it's question 3, so let's see. Learners in a grade 12 class launched a model rocket from rest. Ooh, hold on. Okay. Come on. Thank you. Thank you. So they say they launched a model rocket from rest, vertically upwards from the ground. Assume a rocket experiences a constant acceleration for 1.8 seconds to reach a maximum velocity of. So this is what they're referring to. You can see on the graph. Right, you can see on the graph to reach a maximum velocity of 29.7 meters per second, at which point it runs out of fuel. So at this point here, the velocity is 29.7 meters per second. Now this is when it runs out of fuel. Ignore the effects of air resistance. Okay, cool. Let me zoom it once more. I think 100% will do. All right. Is it enough? 110? Nah, too much. 105 would do. Yeah, 105 would do. Okay, better. Now let's see. So the sketch graph below, not drawn to scale, please note that, represents the position of the rocket relative to the ground from the moment it was launched until it crashes back on the ground. Upward direction is taken as positive. That's very key. Okay, let's see now. 3.1. During which interval or intervals was the rocket in free fall? When was the rocket in free fall? So we will say 3.1. Remember, between 0 and 1.8 seconds, it had fuel. And then from then onwards, it ran out of fuel. So it must be from 1.8 seconds to T2. Okay, these are the intervals. Now let's see. 3.2, or maybe I should write from. Okay, but even what I wrote is fine. All right, so from 1.8 seconds to T2. 3.2. Calculate the constant acceleration the rocket experiences between 0 and 1.8 seconds. We can still use equations of motion in this section, or you can use any other physics equation. Okay? For example, you had initial velocity, you had final velocity, you have the time, you can find acceleration. Okay? But I will use equations of motion. I don't know which one you guys prefer. Maybe let me just do this. Acceleration equals change in velocity over time. So acceleration is final velocity minus initial velocity over time. So final velocity was 29.7, initial velocity was 0, and the time was 1.8 seconds. So what is this? This then is 29.7 divided by 1.8. This gives us 16.50 meters per square second. I should say upwards. And I should have taken this upwards positive. I should have written this before everything. So upwards is positive. And the reason I didn't really emphasize it is because on the statement, they said upward direction is taken as positive. All right? All right. Let's go then. We are done. Now, going to the next question, 3.3, calculate the maximum height H2. You guys see maximum height H2 above the ground reached by the rocket as indicated on the graph. So what we need, we will do this. I want us to do this first. I want us to determine one. I will say, let me do this first. Upwards is positive. Oh boy. Okay. Upwards is positive. So we then say, okay, I'm gonna say height when fuel ran out. Okay, this will be this position here. Height when fuel ran out. Okay, i.e. H1. Okay, so what we will do here, we will still use equations of motion, even if you use, since you know velocity, it's still gonna work. Okay, you can still use a velocity equation. All right, so I'm gonna use, we have final velocity, we have initial velocity, so we also have acceleration, we only need the height. So at this point here, that's what we are looking for. So this, we can say, we know its its velocity here was 29.7 upwards. So it's okay as a positive. And then initial velocity was 0 because the rocket was launched from rest, as you can see, from rest. So this one here will be 0. Just found the acceleration to be 16.50, right? 16.50. This height, let's just call it height 1. Okay. I'm sorry, I forgot to put a square here. 29.7 squared is 882.09 equals 16 times 2 is basically another 16.5. So this must be 33. 32.5? No, it's 33. All right, so equals 33 height 1. So 882.09 divided by 33 will be 26.73, right? Therefore, height 1 equals 26.73 meters. That's height 1, right? So now, from height 1 to height 2, oh boy, from height 1 to height 2, what will we do? What do we have here? We have initial velocity here. We have final velocity here. We know a maximum height velocity is 0, right? So we can find the distance here. So we will use the same equation. We will say final velocity squared equals initial velocity squared. Come on, buddy. Plus 2a delta y. Let's go. What is final velocity? This is velocity at maximum height, h2. It's 0. Initial velocity was that 29.7 square. Once again, we said upwards is positive. What is the acceleration? It's negative 9.8 because it's downwards. And the height here, you're going to say it's, let me just call it delta y for now, okay? All right, cool. So let's see now. We have, if you recall, that we said 29,7 squared was 882,09, isn't it? It was 882,09. This is minus 19.6 delta y. So 19.6 delta y equals 882,09, right? 19,6. Now, where does this lead us? This says our delta y is 45,00, right? So let me just say 45 meters. Therefore, H2, come on, H2 equals 45 plus 26,73, right? So what is 45 plus 26.73? This says our height is 71,73 meters. So the question said, calculate the maximum height H2 above the ground. So this is it. Okay, so this is it. Happy? Great. Now let's go to the next question. 3.4, let's see. 3.4 says to us, calculate how long the rocket was in free fall and hence the value of T2. All right, so with this one, you have to be careful. Okay, with this one, you have to be careful. You know the height here, right? So we can say, once again, upwards is positive, right? Upwards is positive. Now, what will we say? We are looking for the time. We have initial velocity. We don't have the final velocity here. We don't have the time. We have initial velocity and the height. So we'll say delta y equals vi delta t plus half a delta t squared. Now, this delta y is the height when the object ran out of fuel, which was 26,76. You guys remember? But it was above the ground. So, because it was above the ground, we must consider it to be negative 26,76. Initial velocity was 29,7, right? Delta t. Acceleration is half. Acceleration is negative 9.8 delta t squared, isn't it? All right. So simplification will be negative 26,76 equals 29,7 delta t minus 4,9 delta t squared, isn't it? Good. Moving on. We can say this then becomes 4,9 delta t squared minus 29,7 delta t minus 26,76 equal 0, right? Is it 26,76, guys? 26,73, my mistake. 26,73. 26,73. Right, let's fix this. Okay, so you use, let me just write in blue, use quadratic formula to solve. Okay, use quadratic formula to solve. Okay, so for this section, use the quadratic formula to solve. When you use your quadratic formula, you will see that t equals negative 0.88 or t equals 6.86 seconds. So time cannot be negative, right? Now time cannot be negative. Now let's read the question. The question was saying to us, calculate how long the rocket was in free fall and hence the value of T2. So guys, please listen to me. This will become, be careful, the rocket, okay? The rocket was in free fall, okay? Okay, the rocket was in free fall for 6.86 seconds. But what is the value of T2? T2 will be this value here, let me skip a line. So T2 will be 6.86 seconds plus 1,8. What is this? 6.86 plus 1,8 will be 8.66. Okay, 8.66 seconds. I hope you guys get it now. Right? You happy? Perfect. Ooh, we are behind, but luckily we are done. 3.5. Sketch a velocity versus time in your answer book for the motion of the rocket from the moment it is fired until it hits the ground. Clearly indicate the following on your graph. So we have this. Okay, we have this, and I'm going to show you now. They say the velocity of the rocket when the fuel runs out, and the value of time T2 when the rocket crashes on the ground. Remember, the part where the rocket was moving with fuel, its acceleration was 16.5. So the slope will be very high. Okay, it's very steep slope. Do you see this? It's very steep slope. And then the slope when it was moving with regard to, in free fall is different to this one. So it'll be like this. Okay, now let's see. They say, don't forget to show the values. This is velocity measured in meters per second, and this is the time measured in seconds. Okay, let's see. They said the velocity of the rocket when the fuel runs out, it is that 29,7. It's this one here. And then the value of time T2 when the rocket crashes on the ground. So here is it. It's 8,66. This is all that they needed, right? This is all that they needed. If you like, you can also indicate this time here, which was 1,8. All right. And this is it, guys. All right. Bye-bye.